Okay, so we're going to talk about exponential function. We're going to skip that a little. Well, we'll talk about that. We're going to take the, by the way, natural exponential function. Anybody know what that is?
Isn't that e to the power?
Beautiful. E to the x. Well done. So we're going to learn how to differentiate that. We're going to learn how to take the integral of that. And of course, most importantly, be kind whenever possible.
True.
Yeah. Anybody know who said this?
Everybody.
Everybody should say it, yes.
ELE.
Very good. Dalai Lama.
Very beautiful.
So here's, we'll do a little review first. We talked about the natural log function already. Asymptotic to the y-axis, passes through the point 1, 0, has a domain of 0 to infinity, has a range from negative infinity to positive infinity. You take that puppy and you flip it over the line y equals x. The inverse of this guy is e to the x. It's asymptotic to the x-axis. It has a domain of negative infinity to infinity, and it has a range from 0 to infinity. Passes through the point 0, 1. Because if the function passes through 1, 0, then the inverse is going to pass through 0, 1. Remember, e is a constant. So we've already looked at things like x squared. That's a variable raised to a constant. We're looking at a constant raised to a variable. So the rules are a little different here. This just verifies what I already said. They're inverses. This is something you should be able to do. Actually, this requires a little bit of discussion because you probably don't remember this from pre-calc. But when I did this, I took the natural log of e to the x. Do you know how to simplify that? Yes or no? Bring the x out in front. That's a natural log property. So I get x times the natural log of e. What's the natural log of e?
1.
1. So 1 times x is x. Then you have e raised to the natural log of x. That's just a property that you need to know. E to the natural log of anything is at anything. And that's how I solved each of those. They both equal x, and therefore they are in fact inverses of each other. But we knew that already because we looked at the graph. Okay, so again, some more pre-calc stuff. How do I solve that problem, that equation, I should say? Say again? Take the natural log of both sides. Perfect. Why were you laughing? I know what you meant. I understand. Take the natural log. There's two tricks associated with this. One is taking the natural log of both sides. The other one is raising both sides, turning both sides into exponents for an e thing. Does that make, yeah? You know that trick?
Yeah.
Beautiful. Okay. This one is just natural log of both sides. How do I handle natural log of e to the x plus 1?
Just x plus 1.
Yeah, just x plus 1. Move the x plus 1 out in front, blah, 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 we get that, and then x is equal to that. There's the exact answer. If you want a decimal equivalent, the decimal equivalent is 0.946. Remember, AP standard, 3 decimal places, always. Okay, pretty straightforward. Okey-doke. This we talked about already. That's all about the e function, its range, its domain, it's continuous. Yeah, I didn't mention that, but it is. It's 1 to 1. It's concave up. There's some limit stuff. Great. Okay, derivative. What's a derivative of e to the x?
E raised to the x minus 1.
Say that again.
So like x, and pull the x down,
Pull the x down.
keep the e,
Uh-huh.
and then when you raise it, do we subtract 1 from the x?
So just like you were taking the derivative of x cubed, bring the 3 down, reduce it by 1 would be 3x squared. Makes perfect sense, but doesn't work.
Okay.
Okay. That's the power rule that we learned in the first week or so, or first 2 weeks. And that applies to variables raised to a constant. This is a constant raised to a variable. It's much simpler than that. It's its own derivative.
What?
The derivative of e to the x is itself. Yeah, right? I know. You okay?
How does that make sense?
You gonna take a breather for a second? What's the matter?
What if we had like e to the 2 to the,
Oh yeah. What if it's not just x?
yeah, what?
Then you got this guy going on. What's this?
Do you do
I forget.
Why is it the same?
Yeah.
Hold on, let me get my first question answered. What am I doing here?
You do.
What rule am I using here?
The U one is
No.
substitution thing.
No, that's for integrals.
Is it U prime over here?
No, that's for natural logs.
DU.
You flooded it.
Rhymes with pain. Chain rule. Very good, thank you.
I would have never gotten that.
E to the x is simple because this is actually a chain rule too, but what's a derivative of x? 1. This is itself times the derivative of the exponent. And it's just that simple. It's its own derivative times the derivative of the exponent. So here we go. What's a derivative of e to the 2x minus 1? Cricket, cricket.
Two.
Good start. E to the 2x minus 1 times times 2. Okay, don't make it more difficult than it has to be. Itself times the derivative of the exponent.
Why is it derivative of the exponent?
I'm sorry, what?
I don't even know.
Wait, I'm confused. Why is the derivative? Why is it itself again?
Why is the derivative of e to the x itself? Off the top of my head, I don't know the derivation of that question.
Oh,
I can find out.
okay.
I've actually never done it. I just,
Oh, I thought it was like I thought we did it and I just missed it.
oh, no. We're treating it as a postulate, not a
just
theorem.
cause.
Just cuz, right, I like that. But you have to spell it Justcuz, because that's how we roll.
Forgot the space.
Okay. Second one, e to the negative 3 over x times
3x.
good.
Wait.
Why?
It's math magic. That's true. All right, here we go. If the derivative of e to the x is e to the x, what's the integral of e to the x?
E to the x.
E to the x.
Plus C.
Oh, what was that?
Is it with plus C?
Oh yeah, there's a plus c in there. I just neglected to mention it. Oh yeah, sure there. There it is. Next question. Why did I write the same thing twice and just change x's to u's?
Not the same thing.
It's not the same thing, because one's x's and one's u's. Very good, Greg. How does that affect us mathematically?
Gotta do the chain rule.
There's no chain rule for integrals. No chain rule, no quotient rule, no product rule. U du, very good. This is easy. The integral of e to the x is e to the x. The integral of e to something else requires a little bit more work. Many of you will forget to do that little bit of work, and you'll see what happens when you forget, other than you lose points or get wrong. Okay. Here we go. Let's use red this time. What's u? 3x plus 1. Therefore, du is equal to 3 du. So du is equal to 1/3 dx. Whoops, that's a dx, not a du. Come on, Rady. Bush League. Therefore, this becomes 1/3 times the integral of e to the u du. What's the integral of e to the u? E to the u. Uh-huh.
Times 3.
Plus
No,
C.
plus.
Plus C. Indefinite interval gonna have that plus C on it.
Is that like in front of the, is that 1/3?
Yes.
Okay.
If you forget about the UDU business, you're gonna miss this term. And that term's fairly important.
Would we go and substitute 3x plus 1?
Yep, very good. So 1/3 e to the 3x plus 1 plus c.
Is that like simplified?
Demi?
Do we have to show them the stuff, or can we just remember that?
Depends on what you mean by use stuff. Do you need this step? Or you mean this stuff over here?
Yeah.
Wow. I don't know what just happened there, but it was awful cool. Yes, you do need to show this.
It's like an eye.
Looks like a.
I'm sorry, it looks like a what?
Looks like,
Eye.
looks like sideways candy.
It's a little squared, but it's kind of an eye.
Candy corn.
Just go with it.
Yeah, it looks more like.
If you look from the side.
Uh-huh.
Wasn't that supposed to be
Yeah.
square?
How do you look from the side?
We call it
Look
an
from the
SAN.
side. It's not
Smile
like
and nod.
Dave, look from the side.
Is that supposed to be square?
Okay.
Yes, see.
If you look sideways.
It was more like a candy corn.
We're done.
What do you see
Oh, it's
there?
not bad.
Are you sure?
Yeah.
Not bad.
Sure,
Is
it's
that
not like
right?
5.
There's actually an equation that will graph that on your calculator.
No. What is it?
Yeah.
No, there's not.
Okay, I lied. Just want you guys to think I'm cool. So I made things up.
But you did lie?
I didn't
You
memorize
can't.
it. It's ugly.
I'll give you a tie with it.
Thank you.
It's not a fun.
Oh, that's.
So, stop it before somebody else is